In this, I've made data analysis on Census, in which we're going to analyze the big data set using Hadoop. Now, coming to Hadoop, Hadoop is a free Java-based programming framework that offers support to processing of large datasets in a distributed computing environment. This is the folder PRJ, in which I have kept all my Java files, which include all the MapReduce programs and the GUI files like login, state income, etc., and frame main for the GUI using Swing. Now, coming to a MapReduce program, I'll open one. This is a Java program in which we basically perform two tasks. The first is map, and the second is reduce. Now, mapping is a process which takes a data set, converts it into another by breaking down individual elements into the key comma value pairs or tuples. Reduce works by taking the map's output and combining the key value pairs into their smaller set. In this program particularly, we are adding the income state-wise. This is the map function. It takes the key and value pairs as input, the state and the income. In the reduce function, we take the sum of all these values to find out the sum of income for all entries for a particular state. Next, we open the terminal to execute the following. First of all, we change our working directory to the PRJ folder, cd space desktop slash PRJ. Next, we export the Hadoop class path so that we can compile all these Java programs on Hadoop. Next, I compile all the files, all the Java programs in the PRJ folder using the command hadoop space com.sun.tools.javac.main, following by all the names of the Java files. In the end, I've mentioned -d space bin, which means I want all these files to be saved in the bin. It takes a little while executing out. Yep, it's done. Next, I create a jar folder in which all these are present, for which I write jar cvf prj.jar -c bin slash space dot. This basically means that I include all files inside the bin folder. Yep. Finally, when I have my prj.jar ready, the final step is to open the login window, for which I should write hadoop space jar space prj.jar space hadoop.login. This opens my login window. The user ID and password both are admin, and I log in. And there it opens. Now this is a very easy to navigate menu-based interface. This enables end users also to perform analysis on big data. It basically hides all the IT complexities and gives a very neat interface. For suppose now I need to calculate income of states. I press here, then here. When I press show state income, the MapReduce process starts in the background. You can see here. The command has already started. This takes a while. There we have our output on the screen. This is from a sample dataset which was created by us. Now, when I press exit, I can open a new analysis. Now let's take the educational achievement analysis. This analysis basically lists down the average income of those people, of all people with a particular educational attainment. This helps us to analyze that what is the average income of a person who has cleared grade 12 or who has cleared a doctorate degree, an associate degree, whatever. There we have the output on the screen. Now these are the average income figures, annual average income figures. All these figures have been generated using a random function while creating the data set by us, creating the sample data set by us. So well, that's all in the MapReduce program. Next, I would like to show you the pig project. I change my directory to pig.prj, which is over here. In this, I have written a few pig scripts, which are also there in my presentation, which I have submitted. We might just have a look at those pig scripts. For example, income order.pig. Now basically this loads the sample data which I have created into the variable p. Next, I take my data and order it by income, and I store the output in this variable which I would pass through the command. I get back to the terminal, and here I enter the pig shell. There. Now the first step is to execute the script. Execute. In the parameter x we pass pig project1, or we can change the file name. This is actually the output directory which we will find in HDFS. That's the Hadoop distributed file system. Also, we keep the sample data on which we need to perform analysis on HDFS. This is loaded to HDFS using the command -put. Hadoop fs -put the file which we need to move that way. There I press enter. Pig is basically a kind of high level application in which the MapReduce is running in the background and the end user just needs to type in the command. Pig is more efficient for big data as compared to smaller sets of data. Rather, it's very, very efficient for big data. This takes a while. I have set up a single node Hadoop cluster, and obviously that's the main reason why it goes a little bit more slower. There, the query is complete. Now we can open the output file to see how the analysis has gone. Now this is the command sh, which means a shell, moving back to the shell, Hadoop fs minus cat to read the contents of the file named pig project 0 slash part dash r dash 5 zeros, and we enter. There we get the output. This was an input file in which it was in random order. Now we have the output file arranged in increasing order of income. There we can see. And similarly, I've written 4 more pig scripts to perform different functions. So thank you. This is the Census Data Analysis Hadoop project submitted by Shrey Gupta and me, Akshay Khattar, from Maharaja Agresyan Institute of Technology, IP University. Thank you.